All right, well, good evening, everyone, and welcome to the November Virtual Star Party. For some of our presenters, if you can give me a thumbs up if we can be heard pretty well. Adam, all right, thank you very much. So thank you all for joining us on this fall evening, which is about to get a lot more crisp for us here in Middle Tennessee. So I'm Dr. Billy Teets, and I'm the acting director and also the astronomer here at Vanderbilt University's Dyer Observatory. We're a part of the Division of Government and Community Relations here at the university. So we're located here in Brentwood, Tennessee. Be sure to check out our website, dyer.vanderbilt.edu, to see what kind of things we're going to be doing in the future and any updates on when we will hopefully be able to start doing some in-person events. So we've got a great evening lined up for you. We've got a lot of information we're going to cover. One thing I know that a lot of you will be looking forward to is that we're going to have a discussion about some of the things to look for when you are purchasing a telescope. Now that we have the holiday season coming up, that's going to be on a lot of people's minds. So we're going to have some of our presenters this evening giving you some of their expertise on that. So we've got folks from the Bays Mountain Park and Planetarium over in Kingsport, Tennessee. We've got Thea Wellington of the Barnard Seaford Astronomical Society up in Gallatin. She's going to be with us this evening. And then over in West Tennessee, last but not least, we have Jeremy Veldman of the Memphis Astronomical Society. So if you've been to one of these before, you kind of know how we do this, but we're going to have about 10 to 12 minute segments with a few minutes for Q&A. And then for about the last 15 minutes of our program this evening, we will just open it up for questions. And if we don't get to all the questions in each of our different sessions, then we'll make a list of those and we'll try to get to as many of those as we can. So before we start, I also want to thank Helen Morissette and Alex Rockefeller, who are my colleagues here at Dyer Observatory, who are helping us this evening, make sure that things are running smoothly, and also Brian Smokler. He's the technical manager for VU Public Affairs News. So he's making sure that we're going out to the world and taking care of any issues that might arise there. So with that, let's just jump right on into it. So I'm actually going to be doing the first presentation this evening. Unfortunately, it's clouded up, but that's not going to stop us. Let me share my screen. Give me 1 second. So despite the clouds, we're still going to be talking about some objects out there and even have some images. One of those images I was able to capture just before the clouds got too thick this evening. But one of the topics I'll be discussing this evening is this object, which is known as Ceres. So Ceres is an interesting object. You don't have to have a super powerful telescope to actually be able to see this object. In fact, if you've got decent skies and a good pair of binoculars and you know where to look, you can spot this object with a pair of binoculars. So Ceres it was typically known as a main belt asteroid. So this is one of many objects that are orbiting between the orbits of Mars and Jupiter. But Ceres was the first of these to be discovered. That actually occurred back in 1801 by the astronomer Giuseppe Piazzi. So we call these objects typically asteroids because when you look at them in a telescope, they often look like little stars, even though they're definitely not stars. A lot of these are, pretty much all of these are basically leftover remains of our solar system's formation. So there's a whole bunch of these that are orbiting out between the orbits of Mars and Jupiter, but it's not going to be like what you would see in Star Wars, especially like the Empire Strikes Back, where they're flying through the asteroid belt and they're being pelted left and right. If you were standing on Ceres, you'd have a very hard time looking out into the sky of Ceres and spotting another asteroid without a telescope. So space is big, we got to remember that. But this object, despite being the largest of the objects out between Mars and Jupiter, is now known as a dwarf planet. So Pluto is probably the most famous dwarf planet. And the criteria for a planet, according to the current definition of a planet, is that an object has to orbit the sun. It has to be in what we call hydrostatic equilibrium, which basically means its gravity is able to shape it into a ball. And as you can see here on the screen, Ceres is definitely a ball. But the third criteria is that it has to have basically cleared out its orbit from other objects. And that's the thing that nailed Pluto and demoted it from classical planet to dwarf planet. So Ceres, being out there with all these other asteroids, there are literally thousands that we've discovered out there. It has not technically cleared its orbit, and so it's now considered a dwarf planet. But on average, it's almost 3 times the distance from the sun that we are from the sun. So at that distance, it takes it about a little over 4.5 Earth years to make one orbit. Oops. So as we mentioned, it's the largest object in the main asteroid belt. Here it is with a comparison to our moon. So it's about 30% of the diameter of our moon. Okay. Edward Emerson Barnard, he may be a familiar name to you because he was a very famous astronomer from right here in Nashville, lived from 1857 to 1923. One of the things that he did using at the time, one of the largest telescopes in the world, the 40-inch Yerkes refractor, he was able to use an instrument known as a micrometer to actually measure the apparent diameter of this asteroid. And knowing the distance to it, he could then calculate the size. Ends up, he didn't get the size quite right, but still he was able to get some of the first estimates of its size. Now in 2015, the Dawn mission actually visited this asteroid, as well as another main belt asteroid, which is called Vesta. But the view that we have in the bottom left corner, this close-up of this crater, that is one of the prominent craters on Ceres. And it was really kind of perplexing because some of the early images, especially as Dawn was approaching this asteroid, showed some of these white spots, and astronomers were really baffled at the time. But now it looks like these are basically concentrations of different minerals, especially different types of salt. And with measurements from Dawn, we've now deduced that Ceres has a lot of water in it. And so this may be where water has basically percolated to the surface and sublimated out into space and left behind those minerals there, okay? So this is what we would call an active asteroid. There are changes occurring on it. Now, I was talking about some of the images. So this is a sequence of 3 images I captured over a period of 3 days. So that was Thursday night, Friday night, and then luckily I got that 3rd image tonight. And so that object that you see moving amongst those background stars is Ceres. So if you look at it with a telescope, you'll see that it easily moves over just a very small period of time. You'll definitely see a change in its position in a day. So another asteroid that's really been in the news lately is this object called Bennu, because there's a mission called OSIRIS-REx that is in orbit around this asteroid. And what's interesting about this mission is that, well, first of all, it's taking lots of images. This asteroid, by the way, it's not going to be about 580 miles wide like Ceres is. This is actually about 1/4 mile in diameter. So you could easily walk around this object in about an hour or so. But this is what we call a rubble pile asteroid. It's actually just a whole bunch of little bitty pieces that under gravity have basically come together to form this very loosely put together object, okay? So this asteroid is, it's very interesting because it's also another active asteroid. In fact, the bottom right image, you'll see that we've got the asteroid here and you see what looks like a whole bunch of rocks flying off of it. And in fact, there were some images captured by OSIRIS-REx that showed material coming off of this body. So that could be due to heating from the sun. It could be due to meteor impacts. So point here is that this asteroid is still active in some way. Now, Bennu is not just taking pictures of it. Back in about a month ago, actually, it approached Bennu and got very, very close. In fact, it got so close that it actually touched down onto the surface for about 6 seconds. So what we're seeing here is OSIRIS-REx coming down, and this thing sticking down, this is actually a sample, basically a device that is going to grab a little bit of the sample of the surface of Bennu so that it can be returned to the Earth for analysis. And so this came down, and when it impacted, you see it in the diagram here, these little things that are moving, that's actually nitrogen gas that is pumped out. And basically what it was designed to do was as that gas is blown underneath of the sample collector, it catches rocks and throws rocks up into here, and they get caught on the sides of the sample return module. And so then about 6 seconds later, OSIRIS-REx backs off, it fires its thrusters, and it will then, once it's a little ways away from the asteroid, it will then take that sample and it will stow it away in this return capsule. And so this lid would then come down, and then in 2023, OSIRIS-REx will come back by the Earth, and that capsule will be released to then fall back to the Earth. And we will hopefully, if everything goes right, it will survive, won't have any issues, and we will have a sample actually in our hands to study from this asteroid. So it's a pretty interesting mission there. It's just a little time lapse showing some of the images from that actual touchdown. So I've got up here OSIRIS-REx tags Bennu. So that's just an acronym for touch and go. So they basically just went down quick enough to get a sample, and then it reversed direction and got away from the asteroid. And then on the right side, you see two images from one of the cameras on that mission where the sample return module is being locked into place here. And then you can see basically the lid that will come down and seal this in. So hopefully we will get a really nice sample from that. All right, so that is the end from my particular portion of this, or this part of the program anyway. Let's see if we've got any questions that have come up. All right, so for liquid water to be located inside of an asteroid like Ceres, would it also have to contain a magma core? So that's a very good question. So some of these asteroids, so when you have a very small object like an asteroid, you know, even Ceres is what we would consider a small object. That object is going to have cooled off from the time that it actually formed. And so an object like Ceres is not going to have a magma core. In fact, our moon has cooled down so much that it really doesn't have a liquid core like we have here on the Earth. Now, Bennu is much smaller than that. So it's not one of these objects that started out liquid and basically solidified, or it started out as a liquid rock and solidified into solid rock. This is just a bit of material that has coalesced, and it's thought that maybe Bennu is actually the remains of an asteroid that was impacted by another asteroid, and when material was blasted off, it was thrown into such a trajectory that the material didn't really spread apart too terribly far from itself. It was basically able to come back together and coalesce to form this rubble pile. So it's very weakly held together by gravity. And so there's material that would be, that is mixed in with that rock. And so if we have some water in Bennu, for example, then as sunlight is striking it, it can heat the interior of it and cause that material to, since it's out in space, it's going to be very cold. It can start getting that material to liquefy and then, or even sublimate. And as it does that, it leaves behind some of these other minerals like we saw on Ceres. So Ceres doesn't have the active core. It's basically just made up of a bunch of material that coalesced, and that water was kind of trapped in the rocks. And as it's getting heated or impacted, then we might have materials kind of percolating through the surface there. All right, so I don't think we have any other questions at this time. So without further ado, let's move on to our next presenter. And so now we're going to go over into East Tennessee, and we're going to visit Adam Thans at the Bays Mountain Park and Planetarium. And he's going to discuss with us a very beautiful object that we often see in the fall and winter skies. So Adam, you mind taking it away?
Thank you very much, Billy. And thank everyone else for joining us and sharing the night sky. We really enjoy doing this. It's, at some point we will be able to do so in person, but we still want to share the sky with everybody because it is so great. And I'm lucky enough to be able to highlight a very famous object, celestial object in the night sky, and actually something that's very easy to find. And so we are going to be looking at what's called an open cluster of stars called the Pleiades star cluster. And let me change to this picture here. And what you're seeing is a screen capture from Stellarium, a very nice free astronomy program that is good for any platform. I highly recommend that you can download it and use it. It's a great educational tool. So what we're looking at, this is the sky for tonight at 9 o'clock. So I just, this is kind of a generic, mid, evening sky. We are facing east, as you can see, the E in the bottom there. Now, of course, you're not going to see these nice colorful pictures in the sky. These are the constellation mythological sky lore pictures. And just rising off of the eastern horizon, you're going to see Orion, the hunter. And he's sideways and almost, it's just to the upper left of the E. I don't know if you'll be able to see it, are 3 stars for his belt, and then 2 stars for his shoulders, and there's 2 stars for his legs. But when you are in the evening sky, looking up or looking out to the eastern horizon, and if you're able to see those 3 stars for the belt stars, use them as a pointer, as an arrow. And notice that they're pointing almost straight up right now. Well, if you go up, you're going to find the face of Taurus the Bull, where the star Aldebaran is labeled. And you can see this V shape for the face of Taurus the Bull with stars. Keep going to the middle of the bull, and you're going to see that nice little cluster there that kind of looks like the Little Dipper. It is not the Little Dipper. Both the North and the Big and Little Dipper are in the north. This dipper is not a dipper at all. It is a star cluster called the Pleiades. So now that I've talked about where to look, so notice right now, in fact, I'm looking at it right now, it's about 30 degrees off of the horizon, off of the eastern horizon right now. Binoculars are very easy to use to find this. Now we're looking, this is a live view through a telescope. And you're going to see that kind of dipper shape of stars. And this particular cluster of stars is a very young cluster. The stars that you see, the ones that are very bright stars. They are hot blue-white stars. And there's actually about 200 stars in this cluster. The unaided eye will see 6 or maybe 7 stars. A pair of binoculars will show dozens of stars. A telescope will show about 200. Now, the camera I'm using is not like a super duper deep sky camera. So what we're seeing right now is almost kind of like a binocular view of what you would see. And so you're going to see those stars very nicely. The 7 stars, that number 7 might sound familiar to you with this cluster. It's also known as the 7 sisters because of those 7 stars. But again, most people see maybe 6 stars instead of 7. And people with excellent eyesight can actually see more with just their eyes. And again, binoculars will show dozens of stars. And if you happen to know some Japanese, or have I whetted your appetite, or just have a certain car make, giving out hints, you might recognize this pattern of stars the way it's showing right now, because the Japanese name for the Pleiades star cluster is Subaru. And so if you have or see a Subaru car around, look at the emblem, it's the Pleiades. And so get to learn some different languages. So this is a very live view of the Pleiades star cluster. And I have another picture to show you, this one. Now, I took this picture a couple weeks ago, and it is the same cluster, the same camera, but with an exposure that went for a few minutes. Not like 30 minutes, but maybe 3 to 5 minutes or so. Are you noticing something? The stars are really showing the color now, that blue color. You'll also notice this haziness around those stars, this fog or mist. Well, this is in space. What we're seeing is that these stars are traveling through a cloud of nebulosity, of gases. It was once thought a long time ago that that the gas you see is where these stars formed from. But no, now we have very special techniques and instruments to be able to tell the directional movement of the Pleiades star cluster and also that gas. And they're unrelated to each other. Those stars are going through that gas, but it's in two different directions. And so it did not form from that gas. That said, it's still really pretty. And there are some other photographs that you may see out there that are even more, showing a lot more nebulosity. But so this is the Pleiades star cluster with the same telescope, the same exact setup that I've got right now, except it's just a longer exposure. And all of those brighter stars you see that are kind of clumped in the center are part of that cluster. All the other stars in the background are just stars in our Milky Way galaxy, but are much farther away, have nothing to do with that cluster. So that cluster is like a little neighborhood of stars. Now I know Theo is going to be doing another, the double cluster. And so clusters, open clusters like this, generally are hundreds to maybe 1,000 or 2,000 stars. They are loose gatherings of stars. They did all form together in the same area of space, but because there's not a whole lot of stars, not 100,000 or a million stars, these stars will slowly drift apart from each other. They are also found along the disk of our Milky Way. And so if you can see the Milky Way in the sky, that's where you're going to find open clusters. You look out the top or bottom of our galaxy, you won't find as many open clusters at all because they are part of the star formation that is part of our galaxy that happens along the spiral arms of our galaxy. Globular clusters are ancient groupings of stars, clusters of stars, hundreds of thousands to a million or more stars. They are really ancient, almost the age of our galaxy, and look like cotton balls in space. And they can be seen anywhere in the sky. Let me just very quickly. So once again, here is the live image from the camera, and it really looks like we might start. Yeah, we're losing the sky. The clouds are rolling in. So at least you were able to see it. And the stars are disappearing as I'm looking at it. So the clouds coming in front. So the timing was perfect. Let me see if there's any questions. But again, I'll just very quickly repeat. Right now, look to the east, look above the eastern horizon, scan with binoculars after sunset when it gets dark, and you'll find that beautiful cluster of stars all through this whole season. And again, binoculars are a great way to learn about that. So if there's any questions, I'll be happy to answer. No questions right now. Okay. Well, hopefully I explained well, and I'm happy to answer questions later on. And I'll be back a little bit later talking about planispheres and red flashlights.
All righty. Well, thank you so much, Adam. So one thing I just popped in my mind that I'd like to point out is that the path of the planets and the sun through the sky, the ecliptic, also passes pretty much right through the Pleiades. Well, occasionally the planets will pass through the Pleiades. In fact, Venus did that not too long ago. And because of how long it takes Venus to orbit and how long it takes us to orbit, we'll actually see Venus go through the Pleiades right at every 8 years. So it's really cool to check it out, especially in binoculars. Of course, Venus being so bright, it kind of overwhelms the Pleiades, but still it's really neat to see it with that cool background stars. So So thank you very much, Adam. So Theo, we're going to head a little westward now, back over to Middle Tennessee, and get with Theo Wellington up in Gallatin. And like Adam had mentioned, she's going to talk to us about another one of these clusters.
All right. So not quite to Gallatin, only Goodlettsville. It's a little bit closer. Not a lot. And we just got clouded out too. When I first got home, I thought maybe we'd make it, but we didn't. All right, so hopefully everybody is seeing the PowerPoint here, or at least the picture. Okay, here we go. So Adam was talking about one of the more famous open clusters, because it's really stupid easy to see with your own eyes, and I hope you do get a chance to go outside and take a look. If I didn't talk about it in the planetarium, people would ask me, what was that tiny Little Dipper? Was that the Little Dipper? And no, it's not, it's the Pleiades. So there are others that are actually pretty easy to spot if you know where to look. So we're going to just turn a little bit. Adam was looking east. We're going to turn to the northeast and look up, and there is a really easy to spot asterism. It's a constellation, but mostly I see, let's make sure that this is gonna, come on. There we go. Time lag. All right, so there's a W up there in the sky. That's Cassiopeia. If you have a really good imagination, that's a queen sitting in her chair. But if you're like the rest of us, it's a W. So that's the easy part to spot, especially this time of the year. It's nice and high. Then there's a little arc of stars just down underneath it, and that arc is part of Perseus. And if you recognize the names Perseus and Cassiopeia, they go with a whole big long story that was made famous a while back by, what was it? Percy and anyway, I was not the right age for that. My kids were, though. But anyway, it's a famous Greek story about a very vain queen, the hero Perseus, and the beautiful daughter Andromeda. And they're all right there together in the sky, so it's kind of fun that all those groups are there. But if you find that arc of stars, you just head towards the W following the arc. And you can see on the screen that there's a fuzzy thing. And if you've got a pair of binoculars and you do this, you're going to run across this cluster. It is actually a naked eye object on a good sky. So it's right there. We don't generally have super good skies here in Nashville. We're too bright, but a pair of binoculars will easily pick it out. And if we had the telescope view, we did just get clouded out right at sunset here. We wouldn't see quite this many stars through a telescope. This is kind of a camera view, but you would definitely notice that there is a concentration of stars. And then another one, there's actually two little blurbs of stars there. And that's kind of fun. So they have two different names, NGC 869 and 884. And NGC stands for New General Catalog. It was new back in the 1800s. Sometimes things move a bit slow. They're also known as H and Chi Persei. They were given some letter designations as stars, as it were, in that system, even though they're obviously fuzzy things. And because under a dark sky you can see these with just your eyes, they've been known since antiquity. Hipparchus described them. And just like the Pleiades, they are young groups of stars that are kind of newly formed, so they're still kind of close to each other. And actually, even the two groups themselves are relatively close to each other. We think they're only a few hundred light years apart. But you might guess, since they're not nearly as easy to see as the Pleiades, they're a whole lot farther away. They're about 7,600 light years away. So still a young cluster of stars. A lot of them are very blue. Few of them are reds and oranges, some of which are just that color, and others of which are already going through their evolutionary phase of being red giants. You know, a lot of the hot blue stars, especially ones that make some of these clusters so pretty, they don't live long. You would think if you were a big star that you would have lots of fuel. But instead, what happens is the temperature runs up so high that they burn it real fast. So big stars go through their nuclear fuel, they go through making hydrogen, helium, they go through all the way carbon and on up until they hit iron, and then they explode. which is really cool and fun. And I wish we'd get a naked eye one sometime. But I like to tell people that those giant hot stars, the ones we see, are not very old because they just don't last long. They're kind of like the James Deans of the universe, live fast and they die young. But this is two clusters next to each other that are really easy to spot in the sky. And if you take, so I did this last night because, trying to hedge our bets here. But if you take a lot of pictures and pile them up, and then do a little bit of shenanigans with noise reduction and then pushing the color a little bit, you can have a little bit of fun making it a really pretty picture. So yeah, it's just like atoms where you could see the nebulosity around the Pleiades. You don't see this with your eyes, but it's such a colorful and fun thing to do that it's something photographers like to do. So that's this cluster. And actually, this shows up really well if you just have a camera on a tripod and, find that area between that arc of stars in Perseus and that W in the sky and just point your camera there with, a reasonably wide field of view. They'll show up. It'll show up real pretty. And since you're kind of close to the Milky Way as well, that's just an area where a lot of stars. You'll be real surprised if you can take a long exposure. And by long, I mean 10, 20 seconds, something like that. There'll be a whole lot of stars on that exposure and you'll catch this cluster. So I hope you go outside. If it's clear where you are, take us with you, but stroll on outside, look up, find the W there in the northeastern sky, find the curve, and you'll find this cluster. And then you can find atoms as well. All right. Any questions? See if I can quit sharing.
It doesn't look like there are any questions at the moment, but I'm sure others will come up as we start talking about other topics, and thoughts will pop into people's heads. That's the way it works for me anyway. So thank you so much, Theo. That was really neat. And yeah, if you get a chance to look at it with binoculars, it's just absolutely gorgeous. I don't know how many times I've seen it, but yeah, these clusters are just really gorgeous jewels in the sky, I guess you could say. All righty, well, let's now head over to West Tennessee with Jeremy Veldman and of the Memphis Astronomical Society. And as I mentioned in the intro, this time of year, we're starting to get near the holiday season, and this is when we start getting a lot of questions about telescopes. And so, Jeremy, I bet you're going to get a ton of questions following your presentation here, but tell us a little bit about what to look for when you're getting a telescope, or just some other tips that you have to help answer this question.
Well, thanks a lot, Billy. First of all, give me a quick sound check. Thumbs up if you can hear me all right. Excellent. Yeah, so I got about 10 or 15 minutes to cover 400 years of history on the telescope. So obviously it's probably not going to happen, but we would like to get this segment in tonight and possibly in subsequent star parties to give you guys a taste of some of the options that are out there, and then also what to look for when buying a telescope. So I'm just going to go over kind of some brief theory, and then actually show some of the telescopes that I personally own, and then give you some tips also for, if you're looking to shop for the holiday season and kind of get that beginner scope. So I'm going to go ahead and share my screen here and get my presentation up. Hopefully you guys can see this all right. Give me the thumbs up. Excellent. So what do you want to see? So we get, these are kind of the typical things you want to look for when you're getting started. If you never looked through the eyepiece of a telescope before, what do you want to see? Obviously the rings of Saturn. This is a showstopper. I've done this at public events, had one a month ago just before Halloween, and some people looked through the eyepiece of a telescope, saw the rings of Saturn, and the reaction is always the same. They're just blown away that you can actually see the rings of Saturn yourself. The moons of Jupiter, again, that's another thing that just really opens up your eyes to the universe when you see the moons of Jupiter. The phases of Venus also. Venus goes through phases just like our moon does. And when you see that little silver crescent for the crescent Venus, it really is stunning to see for the first time. Obviously craters on the moon, and then also albedo features on Mars, and even some clusters, star clusters. We just saw the double cluster Pleiades. There's several other ones. When you see them through the eyepiece of a telescope, it's really magnificent. So let's talk about telescopes. There's two basic types. There are ones that are called refracting telescopes, and those use lenses to gather light and then ultimately magnify an image. And then there are reflecting telescopes. Those use mirrors. They're not quite as intuitive, but once we get into really what a telescope is, it makes more sense. Now, the purpose of a telescope is to gather light, not to magnify image. I mean, that's kind of secondary. Obviously, you want to magnify your images, but the primary focus or the primary operation of a telescope is to gather light. So it's not magnifying power, but the collecting area is how you qualify the merits of if you will, of a telescope. So the greater the area, the more light that you can gather, and ultimately the more you can do with it. So the size of the primary collecting area is how we qualify the merits of a telescope. So we often use terminology like, it's a 4-inch, or it's a 10-inch, or it's a 20-inch, or it's an 8-inch telescope. That's the diameter of the primary collecting area, whether it's the primary mirror, if it's a reflecting telescope, or the primary lens, if it's a refracting telescope. Now, your eye is a telescope. Your eye has lenses, it gathers light, it magnifies it, it forms an image. The problem is your pupil doesn't gather that much light. A fully dilated pupil is maybe a centimeter in width. So that's why we can't see distant objects very well. If we could somehow extend that, go from 1 centimeter to 1 meter, you're talking about a 10,000 factor increase in the collecting area of the light. So that's really what a telescope does. It's an extension of your eye. It gathers more light and gives you the opportunity to magnify the image so you see more. So I talked about two basic types, the reflector telescope and the refractor. Now, the first telescope was invented by Galileo. That was a refractor telescope that uses lenses. And then following up a generation later, Isaac Newton did fundamental work in optics and figured out a way to build a reflecting telescope that gathered light using mirrors. So think of it as a big light bucket. So that's kind of an oversimplification, but basically those are the two types, those that use glass lenses, refractors, and those that use mirrors or reflectors. And here you can see a diagram of a refracting telescope, a Galilean telescope. And again, you see a convex lens, that's your primary collecting cell that gathers the light, focuses it to a point, and then a concave lens forms the image that you ultimately see at the eyepiece. Very simple design that we're all kind of familiar with. And here is the actual telescope in a museum in Italy that Galileo used 400 years ago to change our perception of the universe, prove that the sun is at the center of our solar system, not the Earth, because Venus has phases, Jupiter has moons that orbit it, and the moon has craters. It's not a perfect sphere. So that is a refracting telescope, the first telescope ever used. Primitive by today's standards, but revolutionary at the time in the early 17th century. Now, a Newtonian reflector, again, uses mirrors to gather light. So here's a simple diagram of a Newtonian reflector. You have basically a long tube, and then you have a parabolic mirror at the back of that tube that gathers the light, focuses it to a diagonal mirror, which is your secondary mirror here, and then brings it out the side, which is where you put your eyepiece. And the first known telescope built like this was in 1668 by Isaac Newton. Here is a replica of the Newtonian reflecting telescope that was presented in 1672. And here's a Newtonian reflector that I own. Now, I got my first telescope when I was 9 years old. It was a small refracting telescope that my parents gave me for my birthday. Owned it for a few years, used it in the backyard, very primitive, but that was a really big deal for me at the time. Fast forward 30 years later, this is the second telescope that I bought, actually. It's a 20-inch Newtonian reflector telescope. Not one that I would recommend for getting started because it's too big and too cumbersome. But you can see here on my driveway a picture of the moon that I snapped through this telescope, and you can see a lot of detail, craters on the surface of the moon. Now, it's a pain to transport this telescope to a dark sky site, which is one of the reasons why I wouldn't recommend it necessarily as your first telescope. Something I was willing to do because I wanted to get a big mirror under a dark sky so I could see a lot of detail. But what's interesting is once this telescope is built and it's in your garage, it is a piece of cake to use because it's on wheels. I literally can roll this thing out of my garage onto my driveway in about 10 seconds and be out looking at stuff on my driveway. Now, of course, it's an urban area with a lot of light pollution, so you're not going to see very much, which is why you got to pay the price to get to a dark sky site for a telescope like this. But if you just want to do some quick and dirty front yard, backyard observing, this actually is really easy to use. And you can see here in the right image that I'm actually pulling it down and looking into the tube, and you can see the primary mirror in the back. And of course, you can get as big as you want. Here's a 24-inch that an astronomer used last month at French camp in Mississippi. So you can get as big as you want with these kinds of telescopes. Here is a Newtonian reflector that I would recommend. And I bought this one a year ago used. This is a 10-inch, again, 10-inch diameter primary collecting mirror. I bought this telescope used for $350. It's about $600 new. And very simple design, very easy to set up also. I can get this set up in less than 5 minutes and I'm ready to go. So if you're looking to do some quick and dirty observing, very good option. And the other thing I love about this telescope is it's easy to store and transport. You can see it here. If you have a small SUV like a RAV4 or a Honda CRV or one of those, fits very nicely in the back. So easy to transport to a dark sky site. Or, if you want to take a road trip to a dark sky site, you could do this too. So very easy to store and transport and easy to set up also. Now, here's a tip. In order to get use out of this telescope, you see the viewfinder on the left and the TELRAD on the right. You need to have a TELRAD. Previous owner bought this telescope, used it once or twice, and then it ended up in basically a bedroom collecting dust for 10 years, didn't really know how to use it and find stuff with it. A TELRAD will help you because it's very easy to find things with a TELRAD. It forms with a little red target when you turn it on. All you got to do is look through it, and anything you can see with the naked eye, or if you have a general idea of where stuff is located, very easy to find with a TELRAD. So if you get a telescope and you're planning to use it regularly, a TELRAD is an accessory you're going to want to get. Now there's a third type of telescope called a Schmidt-Cassegrain. That's like a hybrid of a reflector and a refractor. And it uses a folded mirror design and has a corrector plate on the front. These have become very popular recently. They're expensive, but they're great telescopes. I bought a used one for the solar eclipse. It's a 3.5-inch ETX. I paid $350 for this. And again, I used this for the August 21, 2017 solar eclipse. Put a solar filter on the front. I use this telescope pretty much exclusively for the moon, the sun, occasionally some of the bright planets. But that's about it because it's a small mirror. And you can see here the eyepiece that I bought. It's about $100.
Can anybody else hear Jeremy right now? All right. Jeremy, if you can hear us, I think we've lost your sound. Looks like you're frozen for the moment. While we're waiting for Jeremy to come back, we do have a few questions, and I know that Adam and Theo also have a lot of expertise in this, so we can put out some questions. Actually, Theo, you had provided some information in our chat. One of the first questions was, would it be more cost effective to buy a telescope from scratch or to build a telescope from scratch or to buy one? So Theo, do you want to get a little info on that?
There are some really small, cute telescopes that are kind of like builds. That is, they come with the lenses separate. The Galileo scope is one. It's a very small telescope, about the size of what Galileo used. And so you can put the lenses together for yourself. But in general, to build absolutely from scratch, no, you do it because you love to do things and build things. And so your time is what you put into it. There are some absolutely beautiful builds out there. People do things with fine wood. So it's really cool to see what people do, and there's some fun designs. Sky and Telescope usually has a column every month on home built stuff. Stellafane, where I was referencing their website, is a star party every year. That's really the huge component of it, is people building their own telescopes. But it's like I said, it's really a love. If you like to build things, if you have machine shop type tools and skills, it can be a really fun thing to do. I have some mirrors that my husband started building a telescope back when he was in high school, and the mirrors are in a box. So it's a little bit of a challenge.
Okay, well, thank you, Theo. Looks like we got Jeremy back now, so we'll turn it back over to him.
All right, sorry about that. Looks like I lost my internet connection, so I'm not sure where I left off. But let me actually jump in and give you guys some recommendations for if you're looking to buy a telescope for someone for Christmas. So, and here's just a few recommendations here to consider. So let me go ahead and share my screen. Okay, now full disclosure, I don't own any of these telescopes. So these are just some types of telescopes to consider. And this would fall into the category of my 9-year-old daughter is interested in astronomy. I'm thinking of buying her a telescope for Christmas or her birthday. And again, you can spend as much money as you want on telescopes. I recommend you kind of start small, gauge the interest in the hobby, and then if they catch on, you can always upgrade from there. Now, this is a refractor telescope from Adorama. Again, a little over $100. You get a 70 millimeter Meade telescope on a tripod. It comes with a couple of different eyepieces, a low power, a high power, and then a medium power. The 26 millimeter eyepiece is probably the one you're going to use the most. And you should be able to see that we talked about, rings of Saturn, moons of Jupiter, you know, some of the basic stuff to again, get them a taste of the hobby and see if they catch on. So here's one option to consider. Here's another one by Explore Scientific. Again, it's right around $100. It's a refractor, so it uses lenses. And again, it uses, it has eyepieces that come with it, a couple of different types. I think this one has a couple of Pleiades eyepieces, if I'm not mistaken, which are fairly decent. So again, this is just a good starter scope option to consider. Just go to Explore Scientific USA and search for these specifications. So can you guys hear me okay? Am I still coming in all right? Excellent. All right. And I know we probably got some questions coming up. Now, in the reflector space, again, these are Newtonian reflectors. They don't use lenses, they use mirrors. So think of them as light buckets. Light's coming in and you're trying to gather as much light as you can. Here's a decent option for a starter scope for an Orion, for a Newtonian reflector. And that would be a SkyQuest 4.5 classic Dobsonian telescope. And again, you get the scope, you get a viewfinder, you get a couple of different eyepieces. This one includes Pleiades, which are fairly decent starter eyepieces. And it's on a Dobsonian mount, which means it swivels up and down and it goes round and round or sideways. So it's very simple to maneuver this telescope. And again, pretty good for getting started. So here's another option to consider. Go to optcorp.com. Got a lot of stuff from that website, accessories, and you know, whether it's telescopes or eyepieces. So it's a pretty good option. Here's a tabletop telescope. Again, right around $200 if you're looking to buy new. And again, a 4.5 inch mirror, comes with a couple of Kellner eyepieces and a complete system out of a box that you can get up and running. So if you have kids that are kind of getting into the hobby, you want to gauge their interest, not spend too much money up front, these are some decent options to consider if you're buying new. Now, if you want my personal recommendation on a telescope, again, everybody's got a different opinion on this. I think you should never buy new. Look to buy used, because what often happens is people will buy a telescope, think they're interested in the hobby, use it once or twice. It'll end up in the attic collecting dust, and then they become don't wanters. And eventually they're going to want to get rid of it and willing to sell it at a substantial discount. That is how I bought my 5 telescopes. They're all used. Now, I'm not going to get into eyepieces. We'll discuss that some other time because that's a whole nother topic. If you go to our website, memphisastro.org, we've got some resources for you to consider, including a couple articles on the left on how to buy a telescope. And then also, if you need help with a telescope, a complete guide on basically breaking down the fundamentals of a telescope. Our YouTube channel also has some excellent videos. We have a telescope tip series. We talk about binoculars. We talk about some of the telescopes in this presentation. We talk about eyepieces. So when you get into that, that's a whole nother realm to consider. So, you know, if you want more information, please check out our website, memphisastro.org. And I know Billy is going to be teaching a class on how to buy the right telescope either. So that kind of brings me full circle back to him. So obviously consult with him also, because I'm sure he's got some opinions on this as well. So
I'm very opinionated when it comes to telescopes.
excellent.
All right,
so do we have any other questions?
Yes, we've actually got quite a few here, and you know, we're actually running ahead of schedule. So let's just start going through some of those. And, you know, if we don't get through them all right now, we'll save those to the end there. Let's see. So one of the first ones was regarding reflecting versus refracting. Does one scale up better than other in terms of magnification?
Yes, the reflector. It's the best bang for your buck in terms of size and basically telescope power, because it's a lot cheaper to buy a bigger mirror than it is to buy a bigger lens. Glass gets expensive and cumbersome as you scale up. So typically if you're going after deep sky stuff, whether it's star clusters, galaxies, you're going to want to get a good reflector telescope. That's what I like to do. I like to go after deep sky objects. Now, if you're going to do brighter objects like the planets and the moon, you know, a good refractor is also a good option, but I always have a preference. And again, it's just my opinion, to a reflector, because you can scale it up easier. You get more bang for your buck, if you will.
Okay. Oh, one thing before I forget, we often get the question, or when we are working with especially students that are putting or using a telescope for the first time, they'll look in and they'll see that the object is upside down or backwards, and they'll ask if it's broken. Can you comment on that?
It is upside down and it's not broken. The image is inverted when you use an eyepiece. So yeah, if you look at the moon, you're not going to see it as you would if you're looking at it with your naked eye. And then also, you probably don't tell the difference with some of the other celestial objects. But yeah, you can definitely tell it's inverted because it inverts it when you're using an eyepiece. You don't have that issue with binoculars, and you can use, I think, a Barlow lens to, you know, correct the image if you're in a telescope. But I typically don't do that. It's not broken, it's just inverted. That's just what the lens does in the eyepiece.
Can you hook a camera to most telescopes?
Yes, you can. Now, if you're going to image dim, deep sky objects, you're going to want a tracking mount. And I didn't quite get to that in this part of my presentation, but 2 other telescopes I've recently picked up are Schmidt-Cassegrain type on a fork mount that has a clock drive. So that's one option if you don't want the go-to feature. A lot of telescopes now have the go-to mount, and if you got to get it polar aligned, we won't get into that tonight, but it has to track with the night sky so that it can collect enough light to adequately image. But yes, the short answer to the question is you can connect an image to, or a camera to, any type of telescope.
And could you briefly talk about the different types of telescope mounts? So what's the best for photography versus the self-guiding scopes, or can you use both? I guess elaborate on some of the mounts there.
Yeah, you've got the German equatorial mount. You have, I mean, bottom line is if you're going to do astrophotography, you're going to need some type of polar aligned mount that tracks with the night sky. I'm a quick and dirty backyard astronomer. I don't get into astrophotography as much. So I have a preference to a Dobsonian mount because it's so simple. I mean, it's just up and down and it goes around. I'm just looking for stuff. But if you're going to do more sophisticated astrophotography and things of that nature, you're going to need either a German equatorial or some type of polar aligned mount. And they can get costly, but you're gonna want a decent mount for your telescope that you can align and then ultimately track without any kind of star trails. So we do have a video on that as well on our YouTube channel. So be sure and check that out.
And I guess just following on the tail of that question, what if you wanted to snap a picture of the moon or maybe Venus or Jupiter? Would you need one that tracks for that?
Yeah, no. You should get enough light if you want. Certainly the moon. I mean, you saw what I did with my iPhone. Just lined it. I had no kind of mount or anything. You get plenty of light with the moon. But even some of the brighter planets, you don't need tracking necessarily because they're so bright and you collect so much light. So.
Okay. Let's see. I think we've got 2 more questions here, and we're actually still doing good on time. So it says, I'm not sure how lens size and mirror size relate. So the question of most bang for the buck between the 2 types is something I'm still curious about.
Right. So it's the primary collecting area, whether you're using a refractor telescope to gather light into the tube. We call it the optical tube. So if it's a refractor, it uses lenses. So that would be the larger lens at the end of the telescope, the concave lens. So the size of that will allow more light to come in, and then of course the lens is glass, so it's going to bend the light to the secondary lens, which is where the eyepiece goes. Now for reflector telescopes, it's the size of the primary mirror. So in a Dobsonian, think of a big bucket, and at the bottom of the bucket is a parabolic mirror. The larger that mirror is, the more light that you can gather into the optical cell and ultimately concentrate it to the edge. So that gives you more light gathering power and better capability of either magnifying or enhancing the image in terms of the number of photons that you collect and how much you see. You don't see it as a faint fuzzy. You can actually see more detail as you get larger. An extreme example, and don't mean to get off on a tangent here, but in the mid-19th century, William Parsons built the largest telescope in the world. I mean, he had a huge mirror. I forget the size, but he was actually able to look at the spiral nebula and see structure. And that kind of led us on this trail, realizing that the Milky Way galaxy is not the whole universe. It's just one of many galaxies. But it really began with telescopes, large telescopes, where we could see structure, where before they were just faint fuzzies.
Okay.
Hey, Jeremy?
Yeah.
I was going to chime in a minute here. The biggest refractor most of us will ever own would be about a 5-inch. A 10-inch refractor would be phenomenally expensive.
Right.
Most of us don't have spouses that would stand for the second mortgage it would take. So, but you can buy a 10-inch Dob for not much at all.
Right.
So when you say bang for the buck, that's really where it's at.
Yeah, and I'll just add that, even if you go for, let's say you wanted to get a new 10-inch telescope, you might put a little bit more money up front than what you had anticipated. But these telescopes are really well put together. And if you take care of them, as in when you're not using them, you put the dust cover on it, you don't bang them around too much when you're trying to move them, they will literally last you a lifetime. Even if they get a little bit of dust on the mirrors, which that's another topic for a later discussion, but you have to be very careful when cleaning telescope mirrors because they don't have that protective glass, and literally a Kleenex will scratch it. And I can speak from experience in that. But you can even have some dust on the mirror and you won't notice any image degradation. So putting a little bit of extra money at the beginning, if you're going to use it, then it's a good investment. So
yeah, the answer to the question, what is the best type of telescope to buy? The one that gets used. It's purely subjective. I mean, if you have aperture fever like me, go for it. Get the 20-inch. For most people, it's somewhere between 6 and 10 inches. But ultimately, it's the one that is best suited to you and your needs, and the one that's going to get used, not end up in the attic.
And there was another question. What's the difference between a Plossl eyepiece and a super Plossl?
I don't know the difference between a Plossl and a super Plossl, but in the realm of eyepieces, you typically start off with the Plossls, and then maybe you upgrade to a Nagler, and then you can go to like premium eyepieces like the Ethos set. I've got a couple of those. Those are really, really expensive. It depends on the field of view. Typically, an 82-degree field of view is enough. I got a couple 100-degree field of view eyepieces that I use, but you may not want to spend $500 or $600 on an eyepiece, depending on how far you want to get into this hobby. So there are some good eyepiece options in the $100 to $200 range that will get the job done. And we do have a video on that as well on our YouTube channel. So if you're interested, check that out.
And the different eyepiece names like the Plossl or the Kellner, that deals with more of how many individual lenses are in that type of eyepiece and how they're shaped and paired and whatnot, correct?
Yeah. How many elements there are, how many elements and how many groups there are in the eyepiece, how much glass, if you will, that the light is being filtered through.
One final question here. Where is a good place to shop for used telescopes?
The best place is actually in your local astronomical society. If you're in Memphis, obviously the Memphis Astronomical Society, get on our Facebook group. I know the Barnard Seaford Astronomical Society. I'm sure they have, either a web page or a Facebook page, but get involved in your local community. That's how I found all of my telescopes. Now you can go to cloudynights.com. I think that's a good site. There's one or two others that escape me. Again, go to that document on our page, memphisastro.org. But I would start at Cloudy Nights and get involved in your local astronomical society.
All right.
Everybody calls us up and says, I have this telescope that's been sitting in my closet. Would you like? So yes.
Yeah, you'll be surprised how easy it is to buy a used telescope. There are a lot of people looking to sell.
All right. Well, thank you all for all of that information. As Jeremy was saying, this is just the tip of the iceberg and how, deep we can go into these different things. So, covering 400 years in looks like about 20 minutes, that's pretty good. So thank you for that. All right. And so now we're going to go back over to Adam Thans, and he's going to continue kind of along this line of discussion, but not talking about telescopes, but talking about some other things that astronomers often use when they're observing the night sky. So Adam, want to take it away?
Thank you, Billy. I wanted to add just one little thing to the telescope conversation, and because we get that question all the time too. And in addition to the one you're going to use, you have to consider what are you willing to deal with. If you are able to handle a telescope that is 6 feet long and weighs 70 pounds, great. But if you want something that's real simple and lightweight, put in a backpack or just throw it in the back of the car that weighs maybe 10 pounds, 20 pounds, then you're looking at a very different kind of telescope. And so it's the kind of scope that you would be likely to use based on even just the physical characteristics. Is it heavy? Is it large? Will it even fit in my car? So just little things like that. And Jeremy gave a lot of great information. Astromart is another site for used equipment that is a good site, that people know what they're doing. So I'm going to stop talking about that, and I'm going to talk about basically two accessories. They are not high dollar accessories. These are simple accessories. The first one, and probably your most important accessory, is going to be something like this. I'm going to hold it up to the camera. It is a flashlight, a basic flashlight, but it's red. It is not white light, it is red light. And there's all kinds of red, flashlights that have a red light in them. Why is that important? Well, the way our eyes work. Our eyes, and by the way, I think we're still focused on Billy video-wise. Sorry. Like you're in the main view.
Is mine still showing up?
Yeah. Well, yeah, still is. Yeah, you're still the main view. Sorry, folks.
Yeah, sorry about that. I'm not sure how I can switch that off.
I, I,
Adam, now
there we
you're
go.
in view.
There we
All
go.
right. Excellent. Thank you. I'll redo the flashlight thing. So, special effects. Woo! So it's a red light. That's what's important. It's red. So why is that important? Okay. So the way our eyes work, we have the lens that collects the light in our eye, and the back is the retina. The retina actually has two sections of photon receptors. The middle part are what's called the cones, and they perceive color. The bad part is they're also bad at faint objects, low light situations. Surrounding the cones are the rods. They are excellent at nighttime viewing, but have no color perception, just grayscale. Well, when you're at night and you're wanting to look at the night sky, there's something else that occurs. Your eye will develop a chemical called rhodopsin that helps you see even fainter. So you probably have noticed this. And those of us who are a little older will understand this. You go to bed, you turn off the lights, it's dark in the room. You can't see anything, but you know where the bed is. And then, of course, sometime in the evening, you got to get up and you can see. And that's because your eyes have adapted to be able to see, to be able to perceive much lower levels of light. And so to preserve that night vision, and by the way, that takes about 10 to 15 minutes for that chemical to develop and achieve what's called night vision, to be dark adapted. It takes about 10 to 15 minutes, but to preserve that, you want to use a light that is red, and not a real bright red light, but kind of a dimmer red light. If you use a white flashlight, that's it. Your rhodopsin's gone, and your dark adaptation's gone, and then you're like, I can't see anything. I have this little light that's shining on me for this video, and so when I look up, I see a black sky because I can't see anything because my eyes are used to this bright light in my eyes. If I wait a little while, I can see. So where do you find these things? Well, anywhere. I mean, you go to Amazon, you put in red LED flashlight, and you're going to see 900 varieties. Some of them are in those like head-mounted, helmet-mounted lights that you have straps, and like cavers would use. And some of them have both white and red, which is actually a great tool. And look, Theo is modeling one right now. How fashionable! I think hers should be red, but it kind of looked like it was the white light, but it's probably red. Another is if you are kind of into basic electronics and soldering of wires, you can make your own. What do you need? A red LED. You need a resistor that's the right amount of ohm value to work with the LED, and probably 2 AA batteries or AAA batteries, probably at least 3 volts. And and a switch, or if you want to get fancy, a little potentiometer, a little dial that controls the amount of voltage and thus increases and decreases the brightness. You can use, if you want to be cool, and use an Altoids box, drill a hole for the LED to hold it, and the batteries go in there, and looks cool. It's an Altoids box, so you don't even have to pay for that. You just need the little parts, and you can get all that on Amazon or wherever for real cheap. So it can be as basic as that. Another is, well, okay, coming up in February is Valentine's, and usually those candy hearts are covered with this red cellophane. Guess what? Red filter time. Save that. You can use a couple layers of it. It's kind of fragile, and you can just tape it over the end of a regular flashlight. No cost, other than the candy. So, so, you know, I'm into like very simple solutions that cost next to nothing. It's not because I'm cheap, because I'm not, but it's just, it doesn't need to be fancy. And if you want to buy a flashlight that has a red LED, $5 online somewhere. Second thing I'm going to talk about. This is very valuable of a tool. I have been doing astronomy since I was 12 years old. I am well past that, of course. Let's see, 44 years now that I've been doing this. And this guy right here, not this exact one, but this kind of thing is called a planisphere. I'm going to do it so I don't have the reflection. There we go. There we go. This is a planisphere. What is this thing? This is a tactile object that allows you to dial in the date and time, and then it shows you what you're looking at in here. So it has 2 layers. Okay, you can see my hand. There we go. You see how my hand is in there. So there's 2 layers, and they're held by that grommet. And so around the edge, the perimeter here, if you can see, there you go. You can see the dates, the months and days, and the time, and you just rotate that about. So it's today's date at whatever the current time is, and then that is the sky. So as an example, you see how it's showing a different part of the sky? That's how simple it is. And then this shows you what's up. And you can use this and look and find constellations. This one is made of plastic. You know, it's actually not the best planisphere out there. There are some better ones, but you can even make your own. And guess what? Billy will let you know about how to get to it, but they have on their website free plans to print your own planisphere out of paper. One is color, one is black and white. And also, I think there's a video that describes how to assemble it, how to cut it out and make it. But as you can see, what do you need? You just need a printout for the star chart part, and then another printout with the hole cut, and then a way of, you know, spinning it around. And that's all you need. So you don't even need to spend any money at all. You just print like 2 sheets of paper and you're done. But if you want something that hold up, you want something that's kind of like a thick plastic material that's kind of robust. And it shows you the constellations, and you can find objects in the night sky. So I'm going to stop there because of my time, but if there's any questions related to any of this, I'd be happy to answer. No questions.
I have a question for you, Adam.
Okay.
So is it called a planet sphere or a planisphere? And will you be able to see the planets and moons on these?
Good question. I know you know the answer, though. Okay, there it is. Planisphere with an S, I-S, planisphere. It's actually like planisphere. And he talked about planets and the moon. Well, no. There are very specialty versions that will show the planets. That's a planet finder. That's a different device. This is to show you what's up in the night sky, but just the stars, just the night sky part, because the planets orbit the sun and so does the earth. And so the planets keep, you know, their apparent position in the sky keeps shifting around over time. So I would then recommend Stellarium as an example, free software. It will show you exactly what's up. It'll show you constellations. It'll show you the planets and the moon and the phases. You can zoom in on, say, Jupiter as an example and see the moons of Jupiter labeled, so you know exactly what there is. But if you just kind of want to get out, it's like, what do I want to look at? And this kind of gets you started. I personally like to look at a constellation at a time and objects within that constellation. And especially if you want to get into some of the neat, I'll just plug this, the neat observing programs that the Astronomical League offers. that is a national grouping of amateur astronomers. They have like 70 observing programs, and they're structured to help anybody kind of focus in on certain topics and to be able to learn more about the night sky. But it's kind of like a structured program of active observing. And some of them are as simple as meteor showers or even satellites. Then they get a little harder where it's the Messier objects, which we've talked about. And then some of them get very esoteric, but out of that 70, I would say that anybody could probably do 30 or more of them, 30 to 40 of them. Only a few are like really specific and difficult. So
Okay.
any other questions? Or
Yes, there was another one. Are the phone apps like Night Sky accurate?
I'm not familiar with that particular program, but generally they all are. Some of them have the ability to read the gyroscope in the camera. So as you point the camera around, it will show you, it'll be like pointing and showing you what's behind it, the constellation or planet or moon, whatever you happen to be looking at. And so it's almost like having the VR goggles as you looking around, and it's showing things moving around as you move, but it's the phone. And a lot of them are free. You can just download them and use them and have fun. So yeah, you could use that, but like, okay, your phone, quick tip. I learned this from one of our student interns at the park. I am assuming it's true of things like Android and other electronic devices, but this was for the iPhone and the iPad. In that, if you go under the accessibility settings, you can actually set settings so that it will turn everything to a single color. And typically it's used for people who have certain vision that they need that, but you can set that to be red. And then you can access it by doing 3 taps on the home button, your phone, your iPad, and all of a sudden, whatever's on the screen turns to only red. And that way you can help preserve your night vision while still using an electronic device. And it's a built-in feature of I think all of these devices, but you just, whatever you have, find out how can I change my screen to red? And that'll probably get you there.
Okay. Had no idea about that. I'm gonna have to check that out once we get off of here.
It's pretty cool, actually. Yeah.
Yeah.
You just go to pure red and it works. And unfortunately, unless something is red in the original image, then when you go to all red, then it disappears. The red text or red image will disappear. But in general, if you're looking at notes or star charts or something, red vision, but it's the entire device. So it doesn't matter what you're looking at.
Okay. Thank you very much, Adam. And going back to what Adam was talking about with the planisphere, let me share my screen right quick. So yes, if you go to the Dyer Observatory website, so this is just our homepage, and you scroll on down, you'll see the information for tonight's star party. We've got our regular star charts up here, but we do have the link to the planisphere. So you can click on that and it'll take you to this page, and you can download that file for free. And it just requires 2 sheets of paper. Make sure you don't print it front and back. They have to be separate sheets of paper. And you'll see some instructions here of how to cut it out. But we've also got a link right here, which will take you to, I go through in kind of detailed steps. So it's about 10 to 15 minutes, but it's very easy to cut these out and assemble them. And then Adam has explained to us how to operate them. So very, very handy tool. I've used them extensively, and you can't beat free. So be sure to check that out. All right, so let me stop my share there. And now we're back over to Theo, and she's going to talk to us about a topic we haven't really discussed much about, and it has to do with both Mars and the star Ceres. So Theo?
All right. And I'm going to plug planispheres a little bit too, because a lot of people go, but I've got a phone. Phones are bright, that's one. And two, they need batteries. So that nice paper planisphere will never run out of batteries. So that's my very favorite thing about them. And yeah, I've used them since I was, really small. All right, so we're going to go back out to the night sky just for a moment. Let's see, hopefully that's the correct one. And share. All right. So tonight at about 10 p.m., so let's see, after we get done here, maybe you're taking a late walk to walk the dog. And like Adam said, Orion the Hunter is easy to spot. And by this time, he'll be up a little bit, so, it'll be easy to spot. And then just clearing the horizon is the bright star Sirius. And Sirius, when it's really low, does something really fun. Now, we don't think about it being here on Earth, but if you're looking at the horizon, you are actually looking at 10 times or more as much air as if you're looking straight up. And all that air is in motion. Like tonight, it's a little bit windy here, but we have all kinds of motion of air. Either it's the heat of the day or whatever. That air doing that bounces the light from side to side as it comes toward us, and that makes stars twinkle. The twinkling of a very bright star can result in one color after another reaching your eyes. And Sirius is the brightest star in the northern hemisphere. And so this effect is pretty extreme. So hopefully, give it a minute here to crank up. See if I need to ask it to play. There we go. This was just recorded with a regular camera, and look at that thing go. So we have people all the time that will call and say, there is this UFO parked, over the next hill, and it's flashing all different colored lights. And no, it's just Sirius sitting there getting twinkled really hard by the atmosphere. So that's just a very fun effect, and it's just the atmosphere having a little bit of fun with starlight. Now, on the other hand, when you look at planets, Mars is nice and high and bright right now. And this isn't even hardly going to move much, I don't think, even if it's playing. Let me make sure it is playing. Oops, nope, that's still Sirius. Come on. Get to the next video. Here we go. So this is Mars. And it's just sitting there. It's kind of shifting a little bit, but it's not doing what Sirius was doing. Now, if it were low on the horizon, it would be moving a little bit more. But as a very general rule, planets don't twinkle like stars. And that's one of the ways that you're looking at a planet. Even small planets like Mars are disks. And so even though the light is still being bounced, it kind of averages out over that disk. It's not a single point being twinkled at you. And so you just don't get that same effect. So that's kind of fun. And in fact, let's see if it works, if they'll play. Here they are side by side. So there's a star and there's a planet. Now that's one of the reasons why astronomers really like high mountains and outer space. The Hubble telescope doesn't have to contend with all that moving air jiggling the view. In the last few decades, though, we've come up with a few ways to counter this, because it's pretty annoying and it ruins your view, really. It smears it out. So this looks very Star Wars. But large telescopes anymore have these really cool lasers. And they are lasers of a particular color that shoot up into the night sky. And it turns out that the night side of Earth has a layer of sodium ions way up high in the atmosphere. When that laser hits it, it excites a point of light. Well, that's kind of like a star. And you can watch that twinkle, and they can actually watch that with computers, and they can bend the mirrors to correct for that in real time. That's amazing technology. Here are some of the pads on the sides of the mirror. So this is the telescope's mirror itself, and they can push, and they've got some on the bottom, so they can literally change the shape of the mirror to account for what's going on with the twinkle. So that you can go from a distorted image, you can measure that distortion, and then come out with a really sharp image on the other side. It's amazing stuff. There is actually some little kind of low-grade stuff like this available even for amateurs. Just like Jeremy was saying, it depends how much you want to spend, but it's amazing, and they've gotten so good at it now that they can do Hubble quality work with the large telescopes on Earth. It's still a whole lot easier to go to space, but at least we can correct for some of that kind of annoying. I mean, we need the atmosphere, but it gets in the way. So sometimes it's nice, to not have it. So there we go. So that's just kind of a fun demonstration. So please don't think that that's a UFO. It's just our favorite star. And sometimes actually Venus will do much the same thing when it's very, very low, because it's so bright that it will just, especially here in Middle Tennessee, we have really good rolling atmosphere, and it will just twinkle the heck out of stuff. But anyway, that's a fun thing. Twinkling is pretty, but it does get in the way of your photography. All right, let me kill that. There we go. All right, and turn it back over to Billy.
All right, thank you so much, Theo. Let's see, I'm checking the questions here. It doesn't look like we have any questions at the moment, but we might have some at the end there. All right, well, I guess it's back to me now. So Theo had mentioned a little bit about Orion at the very beginning, and I want to turn our attention back to Orion. Just a moment, I'm going to share my screen. Now, this is a website called spaceweather.com. And it's updated every day, and you can even go through the archives and see the different pages of those days. I'm actually picking November 12th's page because it's got a really nice view of Orion here. There's the belt of Orion, there's his dagger, there's a bright star called Rigel. In fact, if you followed the belt of Orion, just kind of connected it with the line, just kept going on down, you'd eventually run into Ceres there. But I'm bringing this up, which, by the way, can our presenters give me a thumbs up if you can see that? Just okay. Just want to make sure my screen was sharing. So we've got Bellatrix up here, which is forms one of the shoulders of Orion. There's a comet. It's called Comet Atlas, and it's I don't think it's quite at naked eye visibility yet, but it's pretty darn close. You've got a decently clear sky, and you're not in the middle of downtown Nashville, and you've got a pair of binoculars. You should be able to pick this out. But this comet, from our viewpoint here on the Earth, appears to be moving up towards the star Bellatrix. And just turns out that tomorrow night, which it looks like it's going to be pretty clear for those of us here in Nashville, the comet will have moved up very, very close to Bellatrix in the sky. And so you'll have an opportunity to very easily find this comet. Bellatrix is in the top 100 brightest stars. You can even see it from downtown. So it'll be a nice little marker to find that comet. So be sure to check that out. So let me stop my screen share there, and let me share my other screen. Find it here. All right, and let me start my slideshow. Oops. All right, and now share screen. Sorry, for some reason I can't see my mouse. All right, folks, give me 1 second here. I'm having a little bit of a technical issue. Okay. All right, now I should have it. All right, can you give me a thumbs up if you see the sky in November and December? All right, thank you much. So I'm going to focus on two things that are happening this month. In fact, one of them has pretty much already started happening, but that is going to be a meteor shower. So every year we have annual meteor showers. We have a number of them. There's some more famous ones like the Perseid meteor shower, which is in August. the Geminid meteor shower, which is in December. But November is known for the Leonid meteor shower. And so this is a meteor shower that is generated by comet Tempel-Tuttle. So Tempel-Tuttle, those were the two discoverers of this particular comet. And what we're seeing here, and I'd recommend going to meteorshowers.org because this is just a single frame of a really cool animation that they have. But what we see here is our sun right down here, right at the tip of my mouse. We've got Earth in its blue orbit here, then Mars in the red, Jupiter in yellow, Saturn in green, and then Uranus in light blue, Neptune in dark blue. And highlighted here is the path of this particular comet. So you see that it has what we call a very eccentric orbit. It's not almost a circular orbit like we have with the planets, which the planets all orbit in ellipses as well. They're just not as eccentric. They're much more circular, okay? But this comet, it actually goes out about 19 times as far away from the sun as what the Earth is. But then it comes on in to the solar system and gets about an Earth-Sun distance from our star. So this comes through about every 33 years. And every year as Earth is orbiting around the sun, we pass through the tail or the stream of debris left behind by this particular comet. And that happens about middle of November so that we can have the annual Leonid meteor shower. Now, the Leonid meteor shower is named so because when you actually trace back where all of these meteors appear to be coming from. So this is a long exposure image. You see multiple streaks here. And when they're overlaid, they all appear to be coming from a point like right around in here. But that point is known as the radiant. And for the Leonid meteor shower, the radiant appears to be in the constellation of Leo. So there's the constellation of the Lion right there. So the radiant for this shower is right around in here. So the Geminid meteor shower, those meteors appear to come out of Gemini. Now, the best time to see this is in the pre-dawn skies from about November 17th to November 18th. That's when we will pass through the main part of that debris stream. So we're passing through it now. We're just kind of getting the outskirts of it. And so we'll be seeing some meteors coming from Leo over the next few nights and probably into the latter part of November. So this is a view that you would have just before sunrise. You'd have Leo getting about halfway up in the sky. So if we look over in the east, this is about where east is on the horizon, and Leo would be about halfway up. And we would see those meteors coming from that particular direction. Typically, you'll get about 15 of those per hour. So you can expect to see about one every 4 minutes. When you're viewing a meteor shower, don't use a telescope. Leave that at home. Leave your binoculars at home. The only thing that you need is a blanket to lie down on the ground, maybe another blanket to bundle up with. And you just want to lie back and stare up at the sky so that you've got as much of the sky in your field of view as possible. So now, I mentioned before that this comet comes through about every 33 years as it's orbiting the sun. And when it does that, it basically refreshes that debris stream. So about every 33 years, instead of having a Leonid meteor shower, we have more or less a Leonid meteor storm. So this happened about 2001. I was out with some of my colleagues when I was in an undergrad, and we went out to a dark country location, and we just stood out there for about an hour, and together we were kind of counting it out as we saw a meteor. So we weren't double counting, but we counted over 1,000 meteors that particular year. So about 2034 or so, we'll have another one of these meteor storms. So now, switching gears, let's look back at our lunar calendar. So October has some interesting moons in it because we had our harvest moon, which is typically in September. That's the full moon closest to the autumnal equinox, the first day of fall. Just so happened that occurred in October, and that was on October 1st. And then on October 31st, we had the second full moon of the month. And so that was known as the blue moon of October. So that happens for Halloween anyway. That happens about once every 19 years or so. Now, if we go into November, we've got a full moon in November, but you'll notice that it's a little bit different shading than the rest of these full moons. And that's because this particular full moon is going to occur, or it's going to have an eclipse occur during it. So a quick overview of eclipses. Everybody's probably very familiar with the fact that there are two main categories of eclipses. There's the solar eclipse, where we see the moon pass in front of the sun, and basically the Earth goes through the shadow of the moon. Or we have a lunar eclipse, where we see the moon go into the Earth's shadow. So a couple of things to point out here, and we're just going to be focusing on the lunar eclipse for tonight. Notice that the lunar eclipse always happens when the moon is on the opposite side of the Earth from the sun. The only time that can happen is when the moon is in the full moon phase. Just like for a solar eclipse, the moon has to come between us and the sun. So the only time a solar eclipse can happen is during a new moon phase. I do also want to point out that there isn't just a single shadow of the Earth. There are two shadows. The moon also has two shadows. If you happen to be, or if the moon is passing through the penumbra, this larger outer shadow, then the moon would be observing part of the sun being blocked out by the Earth. Okay, just like if you were in a solar eclipse, and most of the time viewers of a solar eclipse are within the penumbra of the moon, and so they see the moon blocking out a portion of the sun. But if you happen to fall through the umbra of the Earth, so if the moon goes through the umbra of Earth, then the moon would see a total eclipse of the sun from its viewpoint. Just like if we happen to stand in the umbra of the moon, then we see the sun completely blocked out. So keep that in mind. We're going to have the moon a full moon, and it's passing through one or more of these shadows. Now, I mentioned before that we've got these eclipses occurring at full moon and new moon. So full moon will allow for a lunar eclipse to occur, and new moon allows for the solar eclipse to occur. We have those phases of the moon every month. They happen about every 29.5 days. So we have a full moon, let's say on Halloween, 29.5 days later, we have another full moon. But we don't have eclipses, like, for example, lunar eclipses every full moon. In fact, they only happen about twice a year. So why is that when we have full moons every month? Well, that's because as the Earth is orbiting the sun and the moon is basically orbiting around the Earth, we don't orbit in the same plane. So what we see here is that this large blue rectangle with the light blue ellipse in it, that is the path of the Earth around the sun. Okay, that represents the Earth's orbital plane. Now, the smaller squares and ellipses, that represents the moon's orbital plane. And the moon's orbit is tilted by about 5 degrees with respect to our orbit around the sun. And so when the moon comes to the point where it's trying to come in, say, between us and the sun to do a solar eclipse, most of the time, the moon is going to be a little bit too high or a little bit too low because of its tilted orbit for us to fall into its shadow. So for example, over here, when we had the new moon and we try to do a solar eclipse, the moon is essentially below us. And so its shadow goes underneath the Earth, misses us. And so if we could see the moon in the sky, we would see that it appears to pass under the sun. Okay. Over here, we basically have the opposite. The moon passes over the sun, still the shadow misses us. And likewise, when the moon is at the full phase, typically it's either going to pass above the shadow of the Earth or below the shadow. So we get a full moon, but no eclipse. But there are times where the moon happens to be at, say, the full moon phase, when it's at just the right part of its orbit, that the orbit has brought it down into the plane of the Earth's orbit. And so then we basically have the sun, Earth, and moon forming a perfectly straight line. And the moon passes into at least one of our shadows. Now, you'll also notice that in this view, we have a red moon. Those are the dramatic total lunar eclipses. So in this view, this was taken back in 2019, January of 2019. The moon had slid first into the outer lighter shadow of the Earth, that penumbra, and then it finally moved into that deeper, darker shadow, that umbra. And so this is during what we call a total lunar eclipse, when it's in that that umbra, that darker shadow. And you see the moon has, instead of a very dark look to it, it's got a very deep red look to it. That's because we have an atmosphere. So as sunlight comes through our atmosphere, the blue light gets scattered out pretty well, which is why sunsets and sunrises appear much redder than when the sun's higher up. It's also why the moon appears to be very red when it's typically rising or setting. But in this case, the full moon was pretty high up in the sky and it was still very red. And that's because the light coming through our atmosphere from the sun, the blue gets scattered out, a lot of the red is able to make it through, and it's also bent a little bit by the Earth's atmosphere. It's called it's a refraction effect. So the Earth's atmosphere essentially acts like a little bit of a lens and focuses some of that red light towards the moon and illuminates that surface. So if the Earth didn't have an atmosphere, the total lunar eclipses would be very dark. They really wouldn't have any color to them whatsoever. Okay. This view is also notable in that if you look very carefully, right here, there's a little white speck. Turns out that a number of people who were photographing this eclipse happened to catch a meteor striking the surface of the moon. Now, this was too dim for the naked eye to be seeing it. So if you happen to be looking at the moon when this happened, you wouldn't have been able to catch that or to catch that. But this is an enlarged view. But some of these more sensitive cameras that were doing these longer exposures did happen to catch it. So the moon is still getting bombarded by stuff, just like the Earth is getting bombarded, especially during these times of these annual meteor showers. So the moon's constantly getting new craters. Okay? But this is not what you're going to expect for the end of November. Unfortunately, we don't have a total lunar eclipse. We have a penumbral eclipse. Notice this one's not nearly as dramatic. So on the left side, we have a quote, normal full moon. The right side, this is maximum eclipse of a penumbral lunar eclipse. So what's happening here is that the moon isn't going really deep into our shadow. It's basically just kind of grazing the outer shadow, Earth's penumbra. So there's still a fair amount of light hitting all parts of the moon's surface. So the moon only gets a subtle darkening towards one edge. And in most cases, if you didn't know it was occurring, especially if you didn't really see the moon that often, you would have no idea that it was actually happening because it's pretty subtle. But if you know it's happening and you compare the moon when it's out of eclipse versus when it's in, then you can see a little bit of a difference. So this eclipse, so these are not the times for this particular eclipse. This was one that occurred back in 2016. But the eclipse, this penumbral eclipse will be visible from the US, but you'll have to get up early in the morning. I think it's somewhere around like the 3 a.m. Period for the central time zone. But it'll last for, I think it's a little over an hour. You'll see that subtle darkening and then it'll gradually get brighter again. So we do have more eclipses coming up, just not, say in the next few months or so. But anyway, be sure to check that out. Because even if it is, it's not as dramatic as the total lunar eclipse, it's still pretty neat to see the moon passing through our shadow because it doesn't happen that often. So let me go ahead and stop my share there and let's see if we've got any questions here. Let's see. Did I say if there was an upcoming Leonid shower that was comparable to the 2001 shower? And I'm sure it was 2001. It was either 2000 or 2001. I don't think it was 2002, but maybe some of you that are out there listening may have seen it and can vouch if it was 2001. But these storms occur about every 33 years or so, because that's how long it takes the comet to orbit. So start really, looking in social media and things, or on astronomy web pages around the year 2033, 2034. There's a group that actually does predictions for annual meteor shower rates. There's something called the zenith hourly rate, or the ZHR. And that's the number of meteors that you can expect to see coming from the shower at its peak time. Basically when the radiant gets as high as possible, so you have the best chance to see these the meteors. It'll give how many you can expect to see every hour. So normally these Leonids will be about 15 per hour, which is pretty neat. Especially if you've got a good dark location. This year, the moon has it's like right at the very beginning of the crescent phase, so it sets right after sunset. So it's not going to be washing out the fainter meteors in the early morning. So this year turns out to be pretty good. Let's see. I think let me check here. Make sure I don't. Let's see, is Betelgeuse exploding? Good question. So we mentioned before that, do I have that? It's not on that picture. But one of the brighter stars in Orion, I think it's technically the second brightest star, that really nice orange star Betelgeuse. Back starting around December of last year, it began to fade a little bit. And we know that Betelgeuse is a variable star. It actually does change its brightness over a period of time. And it actually has what astronomers call a few modes of variation. Basically, there are a couple of different things that will change its brightness, the way it kind of swells and shrinks over time. But so we knew that it does vary. In fact, that's been known for about a century. And it was predicted that it should start to dim, and it was. But the thing was, it dimmed much, much, much more than anyone had anticipated. And it stayed that way for a good period of time. Turns out there's very, very strong evidence that what had happened was that instead of Betelgeuse getting ready to explode, which we don't think it's going to anytime soon, at least not in our lifetime, it's thought that there was actually a large amount of material that was brought to the surface of this star. So it often has these, I wouldn't really call them eruptions, but has these periods where a bunch of material will come up to the surface of Betelgeuse. And that material, if it gets lofted out into space, it starts cooling off. And it happens that this blob of material was actually directed more or less towards the Earth. Now, Betelgeuse is so far away that material will take, thousands, 10,000s of years to, if it were to get to us, to actually get to us, but it'd be so diffuse it wouldn't do anything to us. So don't worry about Betelgeuse sending a blob that's going to destroy us. But what had happened is that material, after it was ejected from Betelgeuse, it cooled, and when that gas cooled, it started forming dust, which is really good at blocking out visible light. So that dust was basically a cloud that was obscuring part of Betelgeuse so that we couldn't see it, and as well anyway. And so that caused Betelgeuse to appear to be dimmer, when in fact, it actually wasn't dimmer. Astronomers observing with infrared telescopes, they were actually using very, very, very long wavelength light. It's longer than what your eyes can see. When they were observing that, they didn't notice really any change in Betelgeuse whatsoever. And dust really can't block out infrared light like it can visible light, the light that your eyes can see. And so there were other observations made in ultraviolet light that showed that there was a big eruption on Betelgeuse just before it started to dim. So when you put all those pieces together of this big puzzle, astronomers were able to deduce that, yeah, there was a big eruption that created a cloud of dust that blocked out Betelgeuse for a little while. But once that cloud kind of expanded out and also kind of got out of our viewing sight, then we saw Betelgeuse return to normal. So when you see it in the night sky, it'll be about as bright as Rigel, which is at the bottom right knee of Orion. But about January of this year, it had dimmed so much that it was about the same brightness as Bellatrix, the star that comet's going to be passing by tomorrow night. So anyway, that's the very long, drawn-out explanation for is Betelgeuse exploding? And the answer is no. There was another question. Any suggestions for binoculars? Jeremy said that he has a pair of Oberworks that he could show. So let me turn it over to Jeremy.
Yeah, can you guys see me all right?
Yeah.
So if you're looking, I mean, we talk about telescopes, but quite frankly, a good set of binoculars is actually a pretty good option for getting started. These are Oberwerk, O-B-E-R-E-R-K. So you could just do a search literally online for these. These were a gift. Brian, one of my buddies, gave these to me. So, your friends in the world of astronomy, when when people give you a free set of binoculars. So, but these are great. They're just simple handheld binoculars, and these are very good for, we saw the double cluster earlier tonight, the Perseus double cluster. This would be an ideal target for binoculars. Other targets would be the Orion Nebula, M42, the Pleiades. We saw that tonight. Very good target for binoculars. In fact, much better in binoculars than in a telescope, because typically a telescope, you're zooming in so close that you're not really seeing a lot of detail. So star clusters, even galaxies, the Andromeda galaxy is a great binocular target. And in the summer sky, Scorpius and Sagittarius have a lot of rich binocular targets. M6, M7, Ptolemy's cluster, the butterfly cluster, as well as several other targets in that area. In fact, this would be something really good to start with under the sky. I'm under a summer sky. So these are 10 by 50 waterproof, long eye relief binoculars made by Oberwerk. Again, Oberwerk. We have done a couple of videos on our YouTube channel on not only the Oberwerks, but some other binocular options. So if you're interested, check that out.
All right, thank you so much. All right, let's see, were there any other questions? I don't see any recent ones. I'm trying to see if we had any that we missed. I think there was one that came in at the end of the telescope presentation. How well do super cheap telescopes work?
Here's my thought on that. If you have somebody that is like a child that is interested in astronomy, again, spend $100 to $200. Get some of the telescopes I recommended, a good refractor, see if it catches on. If it does, then I would say take the next step and look at upgrading maybe a year or two down the road to somewhere between the $300 and $500 range. It works okay if you're trying to gauge interest in the hobby. Here's the danger. A lot of people buy a telescope, think they're interested, use it once or twice, and then it ends up in the attic and they kind of lose interest. That happens more times probably than we can count. So I wouldn't necessarily recommend going out and spending hundreds of dollars on a 10-inch or a 12-inch or even an 8-inch Dobsonian until you test the waters first, see if the interest is there. And then I would recommend, I always recommend a Dobsonian, either an 8-inch or a 10-inch. That's a good starter scope. But you're going to spend a few $100s just on the telescope, and then maybe a few $100 more on the eyepieces. So to get a good optical system, you could easily spend $1,000, and you may not want to do that initially. So short answer is okay. Long answer is it's good for getting started and then kind of gauging where you want to go from there. I'm sure you guys have some other comments on that.
Yeah, Alex actually brought up something I was just thinking about. So how about attending a live star party to see the different types and sizes of telescopes and kind of get an idea of what they're going to likely see in these different things?
Yep.
Okay. Let's see.
And Billy, I got one other comment whenever you're ready.
Yeah, please.
I want to reiterate something that Adam said earlier about the trade-offs of the different types of telescopes. And it really depends on what you're willing to endure. I bought a 20-inch Dobsonian because I have aperture fever. Bigger is better. I wanted to get it out under a dark sky and see these faint fuzzies. Having said that, there's a price to pay, not only monetarily, but when it's 3 o'clock in the morning and you've been out observing for 8 hours and you're dead tired and all you want to do is go home and sleep, and you're thinking about all the steps that you have to go through, breaking down the telescope, packing it up, drive home. It's 45 minutes for me from my dark sky site to my house. Then when I get home, I've got to unpack the optics because it's typically covered in dew or frost, let them dry out. Then I got to take a shower and I'm probably hungry. And then I can go to bed. It's a couple of hours between the time I'm done observing and the time I can go to sleep. And I tell you, that's brutal sometimes. So if you're not willing to pay that kind of price, then a bigger telescope is probably not a good option. So an 8 or a 10 inch, very easy to pack up, 5-10 minutes, you're in the car, you're gone. So that's why we typically recommend something in that range.
Okay. And I was just going to also point out that, you know, when you're, especially if you happen to be in like a department store or something and you see one of these telescope displays where it says magnifies 500 times or whatever, and then you see on the box, here's what you can see, here's Jupiter, here's the Andromeda galaxy, and they show these gorgeous images. Even in these monstrous telescopes like the 20-inch that you've got, you know, you're not going to be able to see what you see on that box. And, you know, even if you have a camera and you put it on one of these large telescopes, to get an image like they're showing on the box is typically, I think like you had demonstrated last month, that's going to often be like, you know, hours of observation just to get that one single image there. So I guess the point here is, you know, when you see all of these spectacular things, don't be tricked into thinking, oh, that's exactly what I'm going to see. Because you don't want to hype yourself up and then be very disappointed. You're going to be able to see things, but you're not going to be able to see it like you see in these spectacular images. You're not going to see a Hubble image when you look through that telescope. The only exception to that, I would say, would be like the moon or maybe Jupiter, Saturn, Venus. But some of these galaxies, you know, they're still, even the big telescopes are going to be like these little faint smudges. So, and I think one other thing I'd point out, we didn't talk about books tonight, but the astronomy magazines like Sky and Telescope and Astronomy, we had recently been emailed. There we go. There's a nice example. We had recently been emailed about recommending a book for someone who is interested in astronomy. And it's a really hard question because some books just deal with you know, basically, okay, here's where you would find this object. And other books are more of just general observation, like here's the different types of telescopes, here are different types of objects you can see. And then there are some books that go into more of, you know, well, here is an emission nebula. Here's what's causing it to glow. And it really goes into the science of it. So, but when I got to thinking about it, astronomy magazines are really great in that they kind of combine all three of those. They have the different sections in there, and every month you get something new. So I'd highly recommend, and this is one of the things that I actually started when I really got into astronomy, was getting these magazines, looking at the star charts, see the new articles every month. And you'll learn so much just from those. You're not going to learn it all at once, but every month you're going to learn something new. And, you know, you'll be surprised after a year how much you know from these. So, we do have another question. Are binoculars better than telescopes?
It depends. It depends on what you're looking at. The wider field of view objects, like I said, the double cluster and even some galaxies are better in binoculars because you can get more in the field of view. Also, you're using two eyes instead of one with an eyepiece and a telescope. There are things called bino viewers that you can put into a telescope where you can use both eyes. I personally don't own one, but I'll give you a quick example. Last year, we went to the Okie-Tex Star Party, 2-day drive at the very northwestern panhandle of Oklahoma. Some of the darkest skies I've ever been under. Took my 20-inch. The highlight of the night was looking at the Andromeda galaxy through a pair of binoculars. And these were image stabilizing binoculars. So they cost $700. They're not mine. My buddy owned them. But I mean, it was really something to see the full Andromeda galaxy in a pair of binoculars. So don't sell binoculars short. It's a good option for getting started.
Yeah, and I can remember when I was first getting into astronomy, we went to my grandmother's who lived out in the middle of nowhere. We brought the telescope with us, but we also had a pair of binoculars. And I was just amazed at just taking, and this was during the summertime, so just taking the binoculars and just scanning the Milky Way and just seeing the endless number of stars up there. It was really breathtaking, you know, as opposed to, say, just putting the telescope, which was a good sized telescope, just setting that up and looking at a very small part of the Milky Way at once. Sure, you could see some stars, but it just wasn't this breathtaking vista that you got with those binoculars. So. Yeah, and as Theo pointed out, binoculars are just a small, very portable telescope.
Yep.
All right, well, we are at 9 o'clock. I think that we actually got to every question that was posed to us. So before we leave for the evening, do any of our presenters have anything else that you'd like to add? You know, it could be about anything we've spoken about tonight.
Sky and Telescope magazine. In addition to what Billy said, I'll mention one other thing. Typically, they have a constellation that they highlight every month, and they'll break down in that constellation different objects of interest, whether it's galaxies or clusters, things that you may not see in regular star charts, and really go into a deep dive on a constellation. That could be your object list for the next observing session. So I'll just double down on what Billy said. Subscribe to a magazine, whether it's Sky and Telescope magazine, which my preference, or Astronomy magazine. You're going to get a ton of great information to get you going.
Yeah, definitely. And I was going to say, when I first really started getting into astronomy, in addition to the magazines, and when I got my first decent telescope, which I think was a 4.5 inch, one of the first things I did was started searching for double stars. It's a lot of fun to look at a star map, and they'll highlight which stars are double with a certain symbol. But a lot of these are stars that are actually orbiting one another, and if they're not too close together, you can actually see them as separate stars. And so for me, that was a big, it was a lot of fun. It was like a game to see, just how many of these I could spot. The other thing that when we get asked about what type of telescope to recommend, we always recommend a Dobsonian. And there are many different styles of Dobsonians now. There are those that are what are known as the classic Dobsonian, where you do all the work. It's just sitting there waiting for you to move it around and look through it. Then there are ones like Orion makes one called the the Intelliscope. That one, it doesn't move on its own. I think it's called the Intelliscope, but it has encoders and a little little computer readout, and it takes it's very minimal amount of setup to get it aligned. But once you do that, you say, I want to look at the Orion Nebula. So you punch that in there, and it doesn't move for you, but it tells you which way to move the telescope. And because the Dobsonians have a pretty wide field of view, they tend to get the objects in there each time. It may not be perfectly centered, but you'll at least see it, and then you can center it. But of course, that requires you to do a little bit of alignment at the beginning. And then you've got the fully computerized ones, which are going to be more expensive, and they're also going to require you to be able to align them, because they are only as good as you are at getting them aligned. So once they actually do know where they're looking at the sky, they're great about being able to point to them. But one thing I've always told folks is that I found it much, much more satisfying if I'm using a telescope and I have to find the object myself. We've got the telescope I use to get the images of Ceres. I push a button and it goes right to Ceres. But, I could do that all night long looking at these different objects. And then after a while, I would get bored. But if I have to find each of these objects and I finally come across the target I've been looking for by looking at star maps and saying, okay, if I go to this star, then I hop over, I should see this little grouping of stars, then I turn right, and then my object should be there. That to me is so much more satisfying than, having a telescope that just automatically moves to it. So we often get asked, can we just go ahead and get one of these robotic ones? And I try to keep people away from that, because if you really start getting into it and you want to put the money into where you can get a good mount, then they'll be great for photography. But if you're just getting into it, don't worry about doing the robotic types. Learning the sky on your own is so much more satisfying. And then afterwards you don't even have to look at star maps. Where some of these objects are. So you get a better appreciation of the sky, because then you learn names of stars, the constellations and all these other things that you wouldn't normally know if you just had a telescope that was pointing for you. So that's my kind of like 2 little cents worth in it.
Yeah, Billy, again, I couldn't agree more. I totally agree. Everybody has a different opinion on this. for me personally, I like to divorce the technology from the telescope.
Mhm.
Get a basic Dobsonian and go out there and develop the skill yourself for finding these objects. It will be more satisfying, and you won't need charts after a while. You'll always have a handful of objects in your head, depending on the time of year, where you can go out and find them on your own. It just, I think your point about it's more satisfying to build your skills at finding these objects yourself. So I wouldn't recommend a computerized telescope off the bat right away either.
Yeah, it's kind of like, doing like a crossword puzzle. I can't get a clue. I don't want people telling me the answer. I could look it up right quick online and put it in there. But if I have to sit there and I'm racking my brain, I finally get it. It's so gratifying. So kind of the same thing there.
And I know even at star parties, I usually take a purely classic small Newtonian, and it doesn't need anything except for me to take a compass and say, yeah, that's north, that's good enough, we're going. And that's if I want to engage the motor drive. And I'm up and going while the other guys are still swearing and cussing at their gears. So, there is something to be said for keeping it simple, especially when, half the year here it's a little cold. Your patience is short. So dealing with, electronics and things that aren't software that's not working. Have you ever had computer software not work? So sometimes, yeah, it's just better to keep it simple and get right to what you want to do and not be messing around.
Yeah, I agree. All right. Well, I've just checked the chat again, and it doesn't look like there are any additional questions. So want to, again, thank all of our presenters. So Adam Thans from the Base Mountain Park and Planetarium, Theo Wellington with BSAS here in Nashville, and Jeremy Veldman with the Memphis Astronomical Society. And then last but not least, Helen Morissette, Alex Rockefeller, my colleagues here at Dyer, and Brian Smokler, who's making sure we're being broadcast out into the world. So thank you all again for all of your hard work on this. And thanks to everyone who joined us this evening, because I know I definitely had a lot of fun. And if you have more questions, don't hesitate to email us. And like Jeremy had plugged for me, thank you, by the way, Jeremy. We'll be doing a presentation next Thursday about telescopes and some other recommended observing aids. So if you participate in that as well, you probably hear a lot of the same things. I'm going to be echoing Jeremy and a lot that he said as well. So be more time for you to be able to ask questions. So, thanks again, and hope everyone has a great weekend.